Hello. In this video, we are going to talk about the four major types of cloud deployment models. Deployment models are defined by where the infrastructure for the deployment exists. The questions that typically define whether or not a deployment model fits in one category or the other is who owns the physical servers, who owns the virtualization software, who gets the phone call if something goes wrong, if the servers go down. The most commonly known cloud infrastructure deployment model is the public cloud. And these are cloud servers that are hosted entirely by an external provider. Someone like Amazon through their AWS, Rackspace, DigitalOcean, Microsoft Azure. These services exist to allow customers to spin up resources on demand, scale up their applications, and all the customer has to worry about is the administration of their servers and the administration of their application. The physical hardware, the networking, the resource allocation, that's all handled by the provider. Similarly, if the network goes down, if the servers crash, a third-party provider tends to be the one in charge of handling the support. Oftentimes, the SLAs aren't necessarily in place, so you need to be careful of what you're looking for. For example, if you have an application that absolutely, positively must remain up 100% of the time, a public cloud may not be the best option unless you plan for network failure by doing distributed computing over multiple data centers. So in a public cloud, if you have your organization servers on the left, the external servers, for example, Rackspace or AWS, handles all of the deployment. You would use their web console, you would use their APIs to spin up new resources, deploy your application, and you wouldn't need to provide any of your own hardware. Now, this provides a lot of great access to scalability and elasticity, especially for startups, where they don't necessarily have the resources to go buy their own servers and hire a server administrator. They offer increased availability and scale. And you get that because the third-party provider, their one job is to keep those servers up and to ensure that those servers are available and able to handle new load. They don't have any other business often. Amazon's a great example of this in that they do have Amazon, the marketplace, but they also have their web services separated. So they have people dedicated just on their AWS teams. So that allows them to have teams that are focused primarily on the servers, on the physical servers, so that the consumer doesn't necessarily need to worry about that. They can just focus on building their application and deploying it to the cloud. They're easily accessible. Oftentimes, all you need is a credit card and a web browser to go spin up some servers and deploy your application. And because it's so accessible, the documentation and the best practices are easily available. Chances are you can find other people who have gone through the deployment steps and the difficulties and the challenges that you may be going through. So finding the community support is a lot easier in a public cloud. However, there are some downfalls to this. For example, if the provider does not have the service you need, like a database as a service or cloud load balancing, you're going to have to build it. And an example of this is, as of the time of this recording, DigitalOcean doesn't offer a database as a service. Amazon offers RDS. They offer a couple different options for that, but not all providers provide all services. So if I wanted to host my database-backed application on DigitalOcean, I would have to spin up a server and manage the SQL installation or the MongoDB installation on my own. That may or may not be a big deal, but it's something to consider. The public cloud is definitely dependent on the quality and uptime of the provider. Now, in the modern era, there's not really a big concern about whether Amazon or DigitalOcean or Microsoft are really putting in the effort into their services. They've made a business out of this, and they're high-quality services. In the early days of the public cloud, there were some questions about quality and There were a lot of cheaper providers, but a lot of that has gone by the wayside. But you still do need to recognize that you are dependent upon a third party. From a legal perspective, there's little control over the other tenants that could be on the same server. For example, if the FBI has to take a physical server because of a child pornography case or some other investigation, you don't have a whole lot of control over whether your application remains on there. Now, a lot of providers will be able to move things around, but you do have to keep in mind that you are not in control of the physical hardware allocation. So you need to trust the external provider that they're going to do the right thing, that they're going to take care of your data. Similarly, there are very few guarantees on physical security. If you're talking about compliance issues, in some countries, you have to maintain all healthcare data on a physically secured system that meets HIPAA requirements or similar regulations. You may not have those guarantees on a public cloud. Now, some providers have stepped into that niche and they are filling that need, but it is something that you will definitely want to consider. Conversely, there are private clouds. Private clouds are managed and maintained by the organization. So, for example, an organization that wants to set up their own private cloud would essentially create their own servers, have their own physical hardware servers, put a virtualization layer on top of them, and then they would make those resources available only internally so that their developers, that their applications can deploy to their own physical controlled servers. They don't have to go off to Amazon or Microsoft. They can actually set up their own infrastructure. Now, there's been a lot of movement in this area for reasons of concerns related to security and control and flexibility. OpenStack is a standard that has gotten a lot of momentum. It's what Rackspace originally built a lot of their cloud servers on. So the private cloud model is definitely gaining in popularity. And the reasons are primarily, like I said, based upon control and security. With your own private cloud, you can control when the servers are getting upgraded, whether they're on SSDs, whether they have GPUs attached to them. Depending on the application, that control is incredibly important. You can also ensure physical security. You can make sure they're behind electronic key doors, that they have logs on physical access. You can also get some more monitoring, some more insight. You can get down to the bare metal, and this may make lawyers and compliance officials happy. However, the costs are significantly higher. You need to have the expertise and training. Computers may be cheap, but people are expensive. And if you're going to have your own hosted internal cloud, a private cloud, then you're going to need server administrators. You're going to need virtualization specialists, networking specialists. You're going to need people to provide support. How are you going to make these resources available to the tenants of the organization? Who's going to control the upgrade path? Who's going to keep things patched? Who's going to monitor the security? These are all things that typically relegate private clouds more towards larger organizations that have those resources anyway. There is increased responsibility. When the servers go down, for whatever reason, you can't rely on a support contract. You are responsible for your own SLA. So a combination of the two is the hybrid cloud. And hybrid clouds are growing in popularity. There's a lot of belief that in the future, hybrid clouds are going to be the future, that this is going to be the dominant model. And the main reason for that is that it allows the control and flexibility when it's needed, but then the ability to take advantage of the cost savings and the scalability and the elasticity that a public cloud may offer. And essentially what that looks like is you've got a public cloud and you've got a private cloud. And they will communicate over agreed protocols, whether it's through JSON-based RESTful APIs, whether it's through sockets, whether it's through service calls. That's a deployment detail, but you'll have your private cloud data, which may hold your secure data, your PCI compliance data, your HIPAA compliance data. And then for the customer facing, for maybe the order processing or the advertising or the marketing portals, those would be out on the public cloud, and they would communicate over whatever protocols make sense. A rarer and lesser known deployment model is the community cloud. And these tend to be relegated to certain niche groups, such as research groups, governmental organizations, sometimes companies working together. Essentially, it's a private cloud that is shared amongst several organizations. So you can think of it as if, 3 universities were doing a major research project. They wanted to maintain their own cloud. So they would set it up, but they would share resources with partner universities. So, for example, maybe the UCLA computer science department would set up their own private cloud, but they would allow University of Minnesota and University of New Hampshire and all these different organizations that were pre-approved to still use resources on that cloud deployment. Now, again, it tends to be more rare and it tends to be more specialized. And a lot of people don't even really consider this any different than a private cloud that's expanded to allow different internal tenants. So one thing to keep in mind through all of this is that the definitions are very loose. As the technology changes, as the technology matures, the definitions and deployment models will shift. Private and public are definitely the most common, but hybrid is growing in popularity. And we see technologies such as OpenStack come in and allow for both a private cloud installation, but to use the same APIs for the public side as well. So you can then merge those two and form a hybrid cloud when needed.